What's poppin', dogs? Mr. Allen here, about to do a little application of some right triangle trigonometry in this video. We're going to calculate the height of the world famous Norge Ski Jump right now, and I actually did this problem in real life. I went out to Norge Ski Jump, got a couple angles of elevation, distance between, mathed it up, and then went to the top with a 300-foot tape measure, strapped a GoPro on it, and dropped it all in the name of math. Just to check my work, right? And it was pretty spot on. It's impressive how accurate this stuff can be with the right measurements. So let's draw this thing up, because it says I took got a 55-degree angle of elevation to the top, walked 34 feet, and then took a second angle, right? Got another angle of elevation of 64 degrees. It's gonna be a steeper angle the closer I walk to that jump. So let's draw it all up, some triangles, and then we'll get to mathing, because the algebra in this thing is actually quite challenging. All right, so my first angle of elevation is 55 degrees. That one's gonna go right here, 55 degrees. Then I walk 34 feet. So that's this distance right here, 34 feet. And then I get a second angle of elevation back to the top. That's this guy right here, 64 degrees. Now, unfortunately, I don't have enough information in a right triangle to solve for any missing lengths at this point in time. However, I could throw some variables on here to hopefully start making sense of some things and maybe be able to set something up. My height right here is the jump, okay? This is from basically eye level up. So I'm going to call this X right here. And then we'll do this length here. I'm going to call this Y. Because now I have a triangle with a height of X and an adjacent side to that 64-degree angle, so opposite adjacent. I can set up a trig function with those two variables. Now it's in two variables, but I can still set it up, all right? So I can do tangent of 64 equals my opposite, which is X, over my adjacent, which is Y. Cool. And I'm going to set up a second one here. I'll use orange for this. I've got another triangle right here, but this side, this whole side, is 34 plus that distance Y right there. But I can still use tangent, opposite, adjacent, boom. So we got tangent of 55 degrees equals my opposite, which is X, over my adjacent, which is 34 plus Y. All right. Now let's take a look at these two equations, because it's definitely overwhelming, all right? But let's try to make a little sense here. Tangent of 64 degrees. If I plugged it in my calculator, I'll do that right now. Tangent of 64, I get 2.05 and change. It's some number, okay? And then over here, tangent of 55, once again, just some number, 1.4 something, right? So I really have some numbers and two variables going on. Tangent looks kind of scary, but we're going to treat it as a number, but I am going to leave it as tangents for the algebra, so it's more and more accurate. You know, YOLO, you only run once. But I also notice an X in each numerator. That would be very easy to isolate algebraically, wouldn't it? I could multiply by Y and by Y, canceling those out, and now I've got Y times the tangent of 64 equals X. That's kind of good. That's kind of cool. Can I do the same over here? Absolutely. I can multiply, let me get that in green, by 34 plus Y. Over here, cancels. And then over here, I'll do the same thing. I don't have a ton of room, but I'll do 34 plus Y. And now let's rewrite it in orange here. I will do 34 plus Y times the tangent of 55 equals X. I now have both of these equations equal to X. What can I do with that? Well, if they're both equal to X, could I set these two sides right here equal to each other, since they're both equal to the same thing? And now I only have one variable, Y. Yes, that was a voice crack. I'm leaving it in. All right, I get one variable now, just Y, with those two. Let's do that, all right? So now I'm going to have Y times tangent of 64, or I could write it as tangent of 64Y. It doesn't really matter. Technically speaking, if we want to write it like, hey, a number, like as a coefficient, I guess I'll do this, times Y equals, and then I got my orange guy here. We have tangent of 55 times 34 plus Y. Okay, so we get a number, tangent of 64 is 2 point something, times Y. Then tangent of 55, 1.4, times this stuff. Well, what should I do with that? Usually we would just, what, distribute our number into the parentheses here? Let's do that, okay? Let's do that. I'm going to switch over to pink now for the rest of this since we have these guys mixed in here, okay? So I'm going to distribute that tangent of 55 in. This guy will remain the same, okay? So I have tangent of 64y equals, and then I have tangent of 55 times 34, so I can put 34 tangent 55, and then I have tangent of 55y. So plus tangent of 55y. Going into my triangle a little bit. It's okay. We don't need that space. I mainly want this space here, okay? Lovely. Now what in this whole algebraic mess? Some teachers will have you just multiply this out and write the decimals there. Again, I'm a yo-yo kind of guy. Round once. So I'm going to keep this thing in terms of tangent for optimum accuracy. And it's pretty dope math moves here, okay? So let's think about what we do algebraically, okay? If I had something super simple, if I had 2y equals 26 plus 5y, what would you do in that scenario? Well, I would subtract 5y on both sides. I'd get negative 3y equals 26, and then I'd divide by that negative 3, right? And solve the problem. That's simple algebra land. Sorry, that's not this case, but we can use the same concept right now. I have a number times y. A number times y. Just a number, because 34 times some decimals, just some number, plus some number times y, plus some number times y. See? Same situation, algebraically speaking. I'm going to subtract, so we'll subtract tangent of 55y on both sides. So minus tangent of 55y. Cool. Awesome. All right, I'm thinking about where I want to fit this here. I'm going to make a little room. I'm going to erase this right here. I'm going to finish up my algebra right down here, okay? Just give me a moment. All right, so now we have tangent of 64y minus tangent of 55y equals 34 tangent 55. Okay, next move. Both of these have y's, don't they? Can I factor out a common factor of y? I can. So I'm going to have y, parentheses, tangent of 64 minus tangent of 55. Double parentheses there, right? I open up a set. This is its own set. This is its own set. Close it all off. Equals 34 tangent of 55. Okay. Now here's the crazy part, because you might not see it yet. This is a number, right? That's a number, right? Can I divide by a number that's multiplied by a variable on both sides? Yes, I can. And when I do that, check it out. Tangent of 64 minus tangent of 55 on both sides. Tangent 64, minus tangent 55. This all cancels out. I'm left with just y. And I can type all of that into my calculator at one time. So let's do that right now, because we've done enough algebra here. It's time to find some information out, right? So alpha x would get you a fraction. Makes it a lot easier to type all this in. All right, so I got 34 tangent of 55. Close my parentheses. Arrow down. And I got tangent of 64. Close my parentheses. Don't miss those parentheses. Those are the most important ones here, because otherwise it throws the other tangent in to that tangent function. So you can miss the top parenthesis guy, but do not miss the one around the denominator 64 there. That will be it'll screw everything up. It'll be very unfortunate. All right, we'll hit enter. I get 78.046 for y. Okay, 78.046 ... That is feet. Is that what I wanted? We want to find the height of the jump. I need x. If only there was an equation that was nicely solved for x in terms of y, which I just found. In case you didn't see me circle that. It's right there, all right? So I can just multiply this, right? If I got y right here, I can just multiply it by tangent of 64, and boom, 160 feet and some change. Nice. So our final answer here, our final answer for the height of the jump, where should I put it? I'm going to put it right here in this blank space. We have 160.018 and change feet. Now, because sometimes we'll throw this in problems here, if you put in the problem there, like, you're observing from an eye level height of like 5.5 feet. Like, I'd be 5.5 feet from my eye level right here. I'm taller than that, right? I'm 5 foot, almost 8. About that. Maybe I'm 5'9". No, I'm not. With my boots on, 5'9". Wait, I did have that. All right. Anyways, so if I said eye level of 5.5 feet, we would add 5.5 feet to that. If it stated that in the problem, you would add that to it. I was kind of on a slight slope and stuff like that, so I was doing a little bit of estimating. I went with 160 feet. You could add in height if you are asked for it, but I'm going to say this guy right here is my final answer for the height of the ski jump, because who knows where I'm observing to in that large box and stuff right there, right? It was basically just a fun little estimate. But again, if the problem here prompts from an eye level of 5.5 feet, add 5.5 feet to that. If it says from a height of 6 feet, add 6 feet to that. Your answer is 166 feet. So pay attention to those prompts in there. But when you're out in the wild and you're just trying to get a rough estimate, use your best judgment. That's what I did out there, and that's actually what we ended up getting when we dropped the tape measure from the top of the jump. My friend down there on the ground, he called out 160, and I was like, wait, what? Like, I was going to, backtrack and fudge some numbers and make it 160 or whatever it was going to be if needed. But it actually worked, and that was really exciting. So thank you guys for mathing with me right here. That's a beefy problem right there. They are all very, very similar to each other. You'll see the algebra work out the same and be plugging the kind of the same thing into your calculator. So if you notice that, you're like, is this always going to work out this way? Yeah, it is going to always work out that way. But pay attention to the different pieces of the puzzle here, and your algebra skills got to be on point. All right, that's about it. Have a wonderful day, guys. See you later.